At school, it was rare for the maths geeks to be the same children who excelled on the football pitch. But now scientists from Leicester University are giving the mathematically minded a leg up when it comes to having a kick about. By studying the radius of a football, the distance from the goal and even the air density, they have developed a formula for taking the perfect free kick every time. To mark the opening day of the Big Bang UK Young Scientists and Engineers Fair on Wednesday, an England international footballer will test a formula for footballing excellence. The formula, developed by physics students at the University of Leicester, calculates how to take the perfect set piece and will be tested by Riva Casley. Taking into account the size of the ball, the density of the air and the distance from goal, the formula can help footballers know where and how hard to kick the ball, to score every time. The formula demonstrates that the distance a ball bends as a result of what's known as Magnus force. This is related to the ball's radius, the density of air, the ball's angular velocity, its velocity through the air, its mass and the distance traveled by the ball in the direction it was kicked. This formula may seem complicated, but in reality it is a mathematical expression of what good footballers do every time they line up a free kick or a penalty, said Jasmine Sandhu, a PhD student from Leicester specializing in physics and space. For instance, if a player standing 15 meters away from the byline kicked an average football so that it was traveling at a velocity of 35 meters per second and had an angular velocity of 10 revolutions per second, the ball would bend around 5 meters towards the goal. She said the formula can also help players become more aware of how they can use spin to bend the ball in a game of football. This uses an effect called the Magnus force. As the ball spins, friction between the ball and air causes the air to react to the direction of spin of the ball. For example, topspin, as Cristiano Ronaldo is famous for, causes the speed of the air around the top half of the ball to be less than the airspeed around the bottom half of the ball. Since the airspeed around the top half of the ball is less than the airspeed around the bottom half of the ball, the pressure is greater on the top of the ball. This creates a net downward force to act on the ball. In addition, this research is also relevant to other sports, such as tennis, which shows that physics definitely gives you the edge, the researcher said. Riva Casley and school children attending the fair will be testing the formula. There's more to being a good footballer than kicking a ball. I'm constantly learning about how science can help me perform at a higher level, said Riva Casley, Oxford United and England footballer. Looking at how a formula can help improve my understanding of how the ball moves through the air after a free kick has been taken will hopefully help improve my performance, she said. Modern engineering is at the forefront of developments in sports technology, added Paul Jackson, Chief Executive of Engineering UK. From sports stars to backroom experts, the sporting industry is reliant on science, technology, engineering and math skills. Maths is the language of science. There are many and varied real-life applications of studying maths to an advanced level, from football to nuclear fusion, said John Mason, Assistant Director at the Institute of Mathematics and its Applications. The Big Bang Fair provides a great opportunity for young people to appreciate all the careers and real-life opportunities associated with maths.